In this session, we'll look into solving of problem number 2. The following data were measured for horizontal axis wind turbine. Speed of wind equal to 20 meter per second at 1 atm and 27 degrees centigrade. Diameter of the rotor equal to 80 meter. Speed of the rotor equal to 40 rpm. Calculate the torque produced at the shaft for maximum output of the turbine. So let's solve this problem. We have given data. We have u naught equal to 20 meters per second. Pressure value is given as 1 atmosphere, which is equal to 1.01325 into 10 to the power of 5 pascals. We have been given the temperature in degrees centigrade, which is equal to 27 degrees centigrade. We'll convert this into Kelvin. So it is addition of 273 to 27, which will give you 300 degree Kelvin. We have diameter of the rotor equal to 80 meters, and omega, the speed of the rotor, omega, is given by 40 rpm, rotations per minute. Okay, so what are the things to be determined? So to be determined, we have to determine torque produced. We have to determine the torque produced at the shaft for maximum output of the turbine. So we'll go to the solution part. So we have the torque produced at the shaft for maximum output of the turbine is given by the equation TSH equal to CT into TM, where TSH is the torque produced, which we have to find out, where CT equal to torque coefficient Tm equal to maximum torque. So we have two unknowns, CT and Tm. So we'll find out what is the first unknown. We'll say first one. To find CT. we have to find out what is the top coefficient. We have Ct equal to Cp max divided by lambda, where Cp max equal to power coefficient and lambda equal to tip speed ratio. Here in this above equation, we don't know what is the value of Cp max and we don't know what is the value of lambda. So what we'll do is first we'll find out what is the value of Cp max. So write down to find Cp max. We have Beck's criterion, wherein maximum Cp is equal to 0.590. So this is the value of Beck's criterion for the maximum Cp value. So we have found out what is the Cp value. We'll find out what is lambda. So to find lambda, we have lambda equal to speed of the tip of rotor blade divided by speed of the coming air. Which is given by R omega divided by U naught, where omega is in radians. So we know the value of R, we know the value of omega, but omega is in RPM. We have to convert into radians. We know the value of U naught. So let's convert omega into radians. Which is equal to omega equal to 2 pi into 40 rpm divided by 60, since it has to be radians per second. So omega equal to 4.1887 radians per second. So we have to convert omega into radians per second from rpm to radians per second. Okay, so it's done corrected. Not just omega has to be converted into radians, it shouldn't be it's not converted into radians, it's converted into radians per second. So it is nothing but we have to convert rpm into radians per second. That's why you have to divide it by 60. Per minute has to be converted into seconds. So we'll substitute the value 40 into 4.1887 divided by 20. So upon calculation we get lambda equal to 83.7758. Since it is a ratio, we don't have any unit. We'll go ahead, we'll substitute the value of Cp and lambda in the equation of Ct. We have Ct equal to Cp or Cp max, both are same, divided by lambda, which is given by 0.593 divided by lambda 83.7758, which is equal to 0.0070. So the value of Ct equal to 0.0070. So we have found out what is the value of Ct. Now we have to find out what is the value of Tm. So the second part of this problem is to find out Tm. So to find the suffix m, we have the equation for Tm is equal to P naught into R divided by U naught. So we have the unknowns here is P naught. So A, to find P naught. How to find out P naught? We have an equation. We have P naught equal to half into rho into A into U naught cube. Okay. So we don't know what is the value of rho and also what is the value of A, where rho is the density and A is the area. So we'll find out to find rho, which is the density. Okay. So as per the gas law, we have P equal to rho into RT. We have the value of P, which is 1.01325 into 10 to the power of 5 equal to rho times R is 287 into 300. So solving this, we have rho equal to 1.1768 kg per meter. So we have found out what is the density value. Once you have found out the density value, we'll find out C, the area. So to find area, we have area equal to pi by 4 d square equal to pi by 4 into day's value is 80, so 80 square, which will amount up to 5026.58 meter square. Once you have found out the area, we will substitute in the equation for P naught. Therefore, we have P naught equal to half times rho A U naught Q, which is equal to half times 1.1768 into A 5026.58 into U naught. U naught is 20 Q. Calculating this, we will get P naught equal to 23.66 into 10 to the power of 6 watts, which is approximately equal to 24 megawatts. We have found out what is the value of P naught. Once you have found out the value of P naught, we can substitute the value of P naught in the equation of Tm and find out what is the value of Tm. So, substituting the value of P naught in the equation of Tm, we have Tm equal to P naught into R divided by U naught, which is nothing but 23.66 into 10 to the power of 6 into R. R is 40, half of the diameter, divided by 20. So which will get you Tm equal to 47.321 into 10 to the power of 6 Newton. So this is the value of Tm. So once we have found out the value of Tm, we can substitute the known value of Tm and also Ct max in the final equation. So therefore, we have Tsh equal to Ct max or Ct multiplied by Tm, which is nothing but 0.0070 into 47.321 into 10 to the power of 6, which will give you a value of TSH equal to 331.25 kilonewton. Okay. So therefore the torque produced at the shaft, therefore torque produced at the shaft for maximum output is equal to 331.25 kilonewton. That's our final answer. This is the end of problem number 2.